I'm Steve Nunn, President and CEO of the Open Group. Welcome to Toolkit Tuesday, where we highlight the various components and leading experts of the Architect's Toolkit, a collated portfolio of the most pertinent technology standards for enterprise architects. During the series, I'll be calling on a number of recognized experts who will bring their particular insights on how to most effectively use the various tools in the Architect's Toolkit. We'll have a mix of interviews, panel sessions, and pre-recorded presentations along the way. While all standards of the Open Group are designed so they can be adopted independently of one another, the greatest value for an organization can be derived when they're used in unison. The sum of the parts should be greater than the whole. In the Architect's Toolkit, we have collated a portfolio of the most pertinent ones for architects together all in one place. For most of these tools, certification from the Open Group is also available, so practitioners can demonstrate that they have the skills required, and recruiters can take the guesswork out of the recruitment process, all backed up by our Open Badges program. Welcome everybody to this special edition of Toolkit Tuesday. I hope you are doing well wherever you are in the world, enjoying summer, winter, whatever it is. I know a lot of us are experiencing unusual weather, unusually hot for the Western summer, but I hope you're well wherever you are. Thanks for joining us today. I'll get to a little bit about the introducing our speaker and what we're talking about today in just a moment. But for those who may wish to ask questions of our speaker today, I just want to take you through how you would do that. We do that through Slido in the WebEx tool. So there are three little dots in the bottom right-hand corner of your screen. If you click on those, the option to open Slido is there. So please do use that. I'll be monitoring that, looking for any of your questions. Please do use that for questions. We also have a chat channel, which hopefully you can see. And one of the things we love to do here at the Open Group, we're proud of our global audience. So please do take a moment to pop in the chat where you're joining us from today. We'd love to know that. And obviously any other messages that you want to convey to the other attendees on the call today. So today we are going to be looking at UDDL, which is the Universal Domain Description Language. It's a standard of the Open Group, and we have a true expert on it joining us today to take us through it. Our speaker is Gordon Hunt. He is co-founder of Scale LLC and a retired US Navy engineering duty officer captain with more than 30 years of experience leading complex defense embedded and distributed systems programs. Gordon is a recognized expert in modular open systems approaches, data-centric architectures, and real-time systems integration, with deep experience connecting standards, engineering practice, and deployed mission capability. He's been an active contributor to open architecture standards for more than 2 decades now, including significant work with the FACE technical standard and the SOSA data model subcommittee. Gordon holds aerospace engineering degrees from Purdue University and Stanford University and brings a practical, mission-focused perspective in interoperability, integration, risk reduction, and accelerating capability to the warfighter. So delighted to have you with us today, Gordon, on this Toolkit Tuesday special edition. Thank you for joining us, and I will hand over to you and see you afterwards for any Q&A. Welcome.
Excellent, thank you. Let me share my screen. And please confirm that it comes through.
Yes, indeed, sir.
Excellent, thank you. Welcome everybody from wherever you are. Good morning, good afternoon, good evening. Yeah, I think this is gonna be, I could easily talk about this for a couple hours. So I'm gonna try to keep it to 30 minutes and really just introduce UDDL to you. Talk a little bit about why, how, and what it's for, where it's leverageable across a variety of architectures, and let's get to it. All right, so that should switch next. Excellent. All right, so fundamentally, what we're talking about is the universal domain description language, and just what it really is. I want to kind of focus on the three main takeaway points. One, an authoritative source of truth for data documentation. So you say, why this? Well, it's not just IDL or XSD or protobuf, and I'm not picking on them, but it's just those are syntax only formalisms, and UDDL brings a semantic rigor to documenting data in embedded real-time data exchanges. So we'll talk about that a little bit as well. Two, the formal model lets you do actual analysis on the interfaces. So you can begin to open them up, look for changes and differences of meaning across many different layers of elaboration. We'll talk about that. And then again, because it's an open ecosystem, lots of people can get in there, manipulate the core models, process them into whatever format they need for their engineering processes, modeling pipelines, code generation exercises, or anything like that. So we're not just talking about a different syntactic language for modeling information. It really is, I think, very, very different. All right, so when I say different, I do ask you to kind of think critically about this. Most folks think about data exchange in real-time embedded systems the way that they talk. I have a structure and an implied meaning. I put words into that. I say it out loud. That's the syntactic exchange over an audio mechanism. But fundamentally, the actual meaning of what you said is buried in your brain, and it is derived or informed or kind of, I hear what you said, I see what the syntax is, and now I have to basically back out what you mean, the semantic. And by that, what do I mean, right? So again, we're very familiar with the block on the yellow, which is kind of a syntactic definition in a very simple way. And that very simple structure can have many different meanings. It can be the controller reporting position of the controlled asset. Again, you see a list there, but it's not clear. And so the way that we try to make ICDs clear is we change those data structures. We add labels, characters in front of the pause data structure. Well, that makes that structure unique to that one. Oh, I want to reuse that structure across all my code. I'm back to a generic structure with implicit meaning. And so then we write many paragraphs into an ICD. Again, not wrong, but not formal and not analyzable. So UDDL brings a formal method to document not only that structure, but then pin to every value and property in that structure a semantic meaning. Right? And semantics, when you do integration across disparate systems, especially when your team doesn't own them all, is really, really important. All right, so again, when we say, well, why do we want to model our data? So again, why do we do digital engineering at all? Well, it enables economies of scale. I can revisit previously modeled or documented interfaces. I can calculate impact of change. I can run regression analysis. I can figure out if I make changes to this component, what else, the ripple of change, how do I isolate that ripple? So every time when I start touching software in an embedded system, I'm not recompiling the entire integration layer, the entire middleware, or somebody changed a data type somewhere and some other application 4 nodes away crashes and nobody knows what happened. So again, we're trying to get information into a model, not only for code generation, that's just syntax, but we really want to leverage the structure of the model to be able to weigh and measure changes of meaning, changes of intent, changes of structure, accordingly, and then make those models reusable and extensible by developers, not the owners of the model, right? So again, really trying to get reuse of the systems. All right. So what are we talking about when we say UDDL? Well, UDDL came out of the FACE reference architecture. It was split out into its own standard in the 3.1 version of FACE. It is comprised of a couple formal language definitions. One, a MOF, meta object facility definition of its structure. So this is really just saying, here are the elements with which we use to build the model. Here are all the relationships between them. And then there are object constraint language and EBNF formalisms that tell us how the model is put together. This allows us to truly assess the proper connectivity of a model. You know, again, when you do a lot of modeling, think Visio. Again, not picking on Visio, but it creates great pictures, but a lot of the connected tissue is implicit. You have to look at several different pictures and go, I see how this impacts this other thing over here. And UDDL and the formalism says, no, this element is realizing that element is related to and connected to this element. It is forming a formal documentation in these 5 interfaces. All of it's connected. And that gives you that rigor that you need to actually go back, revisit, reuse, and regenerate products from that model. The FACE technical reference architecture builds on top of that formalism, adds language binding mappings to the 4 languages presented there, and then also a structured-based formalism for how you get code types out of UDDL. And then it provides modeling constructs, building blocks. They call that the shared data model. We'll talk about that in a little bit, but fundamentally, think of it as the seed for the model. Here are the basic building blocks with which I can build my UDDL model. The other thing that FACE adds, and again, an adopting organization may not leverage these portions of the, the FACE portions, but they can build their own. Here's how I define a module or a service and a component. This component has an interface, it has a port. This port has a data type. That data type is defined by UDDL. And that's kind of how that binding starts to happen. Okay, so if we get into the formalism, right? The kind of the source of truth. The products on the right represent, many of the downstream artifacts that folks have been transforming UDDL into. And again, not one of them is canonical or defined by the UDDL standard. Those are system and product and engineering and company specific transforms. How do I want to render this formal definition of a piece of data and its meaning into one or more of these products? And that gives you one model across many, many uses. And it gives you traceability between, say, a data structure in your code, your SysML block type, your HTML documentation, and maybe your IDL and your protobuf, because you have a multi-protocol based system. And so you get traceability and versioning control across all those different renderings of the data in your system. Again, one model used many different times. And it's not just the automation of it, it's the consistency and the tracing and the long-term technology independence that it gives you. Again, if you think about how your engineers have often done this, it's read a couple thousand pages of documentation, form this map in their head of what the relationships are between all these different products, and then go forth and do something and then quickly purge all that data from their brain. So UDDL provides a way to capture that and reuse that over and over again as the systems are evolved, maintained, sustained, et cetera. The little note on the bottom, UDDL to 1.2. So the current version of UDDL is 1.1. 1.2 is in company review at Open Group. And what's interesting there is that we've actually extended the syntactic formalism of the modeling language and rigor, and that makes it even more accessible for folks to build and derive these generated products. You can leverage many of the MOF to text transform engines. A page or two of transform script will transform UDDL into any or all of these products. It's very, very clean, a lot simpler. All right, so, and then when I say there's lots of products out there, I mean, this is just a snapshot of a variety of products of the UDDL rendering in a couple different tools, language, code base, there's code on the right, generating HTML documentation in the middle, SysML models and other graph-based models. The little color box in the bottom is actually calculating versions of another standard, but just what changed between version 1 and version 2 across many different layers of elaboration. So not just the syntax, but say units, coordinate system, frame of reference, and also meaning. It's not the current position, it's the predicted position. So you can begin to trace all of that across the models. And then version models, and then be able to branch and bring models back together. All of that is possible. All right, so again, once you get that formal model, right? Again, this is where UDDL does not provide in its standard how to do these things. It gives you, here is the formal model, and here's where all of these elements are documented, and version management, comparison analytics, merge analytics. These are things that customers of UDDL are actually doing with the model format. Again, it's just part of the benefits gained with UDDL, but being able to take a node or an element in your interface specification, this value status message has an X field, and being able to trace that to all previous versions of all other messages with that same value in it or that same concept in it, and then trace that to other protocols, other interfaces, other renderings, and get that linkage, lets you do version comparisons and merge. Very, very cool. It turns your data documentation, which once was paper ICDs, into digital engineering, modeling, rigor, and practice. It's not just a document, right? So if we look at the UDDL model itself, again, it's just an XMI file. The canonical form of UDDL is XMI, and I'll show you a picture of it at the end. But it's a graph-based linked model. There are tools that are provided by the Open Group FACE Consortium at this point, but they're open and freely available tools to measure and assess the conformance and the constructed correctness of the UDDL model. There are open SysML plugins and profiles or tools that help you build and maintain this. But again, it's just how do you make it easy? So again, XMI, very portable. There are no graphics. I mean, you can put it into a SysML model and render a graphical picture of how your model is put together. If you like, a lot of organizations are doing that. Or I bring the UDDL model into my SysML model, and I have a SysML component with an interface and a port and a data exchange type, and that's where the linkage to UDDL sits. Again, open ecosystem, lots of folks are really stitching it in very interesting ways. Okay, so parts of the data model. So I've said levels of elaboration a couple times. So again, I think it's important to know that these levels of elaboration are baked into the rigor, and they are connected in a graph-like way. So we look first on the right-hand side, and what most people think about when they think about an architecture and a sequence diagram or a port with a data type. There's a data type, it has some sort of syntactic representation. That could be an IDL, XML, it could be a SysML block with attributes pinned into it, parts and participants, doesn't matter. It's a structured piece of things. So that's your syntax. What UDDL brings to the table is a formal definition of syntax. Again, easy in UDDL 1.2, that is even easier to transform out into all the other products. And we take that data structure syntax and we bind that with a query. Now, a query is a formal definition of what that property means. So this position is the air system's air vehicle's sensed position. It's the air vehicle's nav system's predicted position. It's the mission planning system's desired position of the aircraft in an hour. It's the manufacturing assembly's desired, again, this UDDL is domain agnostic. It's just, it provides you a way to take all of those words, again, if I say see spot run, well, spot is a dog, it's running, it has velocity, and there's an observation element where there's some eyeballs looking at it and you see spot run. UDDL provides a way to actually codify the semantic of that statement and connect that codification through those layers of elaboration. So the primitive layer is your native language data types, floats, shorts, ints, doubles, all those kinds of things. The logical layer brings in measurements. So those are your coordinate systems, frames of reference, units, transforms between those things, temperatures, Fahrenheit and Celsius, densities, pressures, those basic things are all layered in there. And at the conceptual model, that's where you start talking about your domain of discourse. So I have, a dog that has velocity. I have eyeballs that can see the dog. So now I'm talking about see spot run in meters per second represented as a double. And that's what the query actually lets you document. And then within this model, there are a couple things that when you start looking into UDDL, you'll hear people talk about the shared data model. So this is basically your basic building blocks of those core observables. So think position, velocity, acceleration, orientation, rotation, density, pressure, like those basic things. And then measurements of those. So here is velocity measured in meters per second in a Cartesian coordinate system, on and on. And those are reusable assets. And then when I build what's called a domain-specific data model, this is adding your domain-specific entity model, again, reusable, because we talk about the same things many different ways. An air vehicle really only has one position, but it is discussed and sent around in a mission system many, many different ways. So the entity model of aircraft with position is a reusable asset. The queries are built against that, and we can start talking about, those differences of semantics of position. And then we talk about USM, or user supplied models. This is where you start binding the data type, its semantic definition, the entity model, and all the building blocks together into a full model that tells me this unit of software in this system is expressing this data, which means this. All right. All right, so where this gets used, let's talk a little bit about who's really leveraging UDDL within the open group at this point. So the FACE technical reference architecture leverages UDDL to document the data types that are exchanged between their portable components. And these are the data types that are presented by the portable components to the integration function called the transport service. So that data structure has a native language binding rendering. So it'll turn it into a C++ or C or Java or Ada code structure. And that data type is exchanged between the portable component or the platform specific component and the TS. And because of the formalism, I can actually then do FACE then allows you to do formal interface checks on the portable component to include linker. Is the data type actually the same data type that the model says it is? Is it all lashed up, et cetera, et cetera? So FACE is documenting that data exchange there. There are also folks leveraging the FACE technical reference standard to use UDDL to document what would be the data payload in a protocol. So now I have a model that maps the information in a protocol. Let's say it says ABCD XYZ. That's the protocol, to an interface. Let's say it's A and X and Y. So now the transport service has a model of data coming in and then how that data is presented to a reusable piece of software. And that integration layer is all calculable from the model. All right, SOSA is leveraging UDDL as well to document the data between these SOSA modules. Again, so how do we define the data and the payload between the modules? We talk about informing that interaction binding. There are verification authorities. This is getting into SOSA conformance, but fundamentally UDDL serves the backbone of the formalism of the documentation of the data. And then when those systems go to be integrated, that formalism provides fit, form, and meaning of that data type to the integrator of that SOSA module. All right. I know this has been quick, but let me summarize real quick what we're doing, and we can get into a Q&A, and I have examples. We can go down as many different points as you would like, but really UDDL is trying to take the meaning, the semantic. It's not just another ICD syntactic definitional language. I mean, a lot of people are using UDDL just to generate code. That is a syntax to syntax transformation. It's a not wrong use, but it is not fully exploiting what's really in the model. So the model captures the syntax, yes, but then binds to that syntax the explicit meaning of each of the attributes or the fields in your data type. So I can then begin to trace that meaning across all of the different implementations, across all the different protocols and all the different software modules. And so it's trying to decouple semantic from an API where it says set current temperature, max temperature, and then it just provides a float. Well, in that case, the meaning of that float value is in the string label of your API call. And UDDL tries to move that into, here is a data exchange, it's a float, it's a temperature, it's in Celsius, and it's the set point for the, your bedroom before you go to sleep, whatever that the model says. The formalism, again, UDDL does not specify how it gets rendered into SysML or any other modeling language. It's just an XML folder file, and the rendering of that is user specific. There are OMG offers a standardized UDDL and face profile, but again, I've seen folks build their own there. It enables, this reduces implementation-driven distortion. This is really important. I've seen this in practice where folks start talking about what did you mean by that value in that interface? And when you present them with the query, basically, this is what I meant. It is the sensor's sensed value of this machine's device, its operating temperature or position or whatever. You can actually have a formal conversation about, no, that's not what I meant. When you start using words and you write a longer paragraph, the actual meaning gets lost. Change management, again, because the model lets you hold multiple versions of the interface in the same model, very easy to difference it. That's kind of hard to do when I have a data type in an ICD called position status report. And I can make V1, V2, V3, and I can make those all syntactic, but the differencing becomes an exercise to the reader. Or worse, I just have position status report and I don't know what version it is, and I have to actually go back and look at other code to try to trace that all out. And then again, I've seen lots of one-off tooling patterns where people are trying to add this degree of formalism to their CI/CD and their DevOps pipelines, but it's based on a modeling paradigm or a schema or an approach that they invented. Again, this standardizes the documentation of data across industries and lets folks leverage tools, exchange data, more readily integrate, et cetera. All right, I will pause up here for a moment. I think we can go to questions. If you would like, I can go to examples, but yeah, I'm happy to take questions. You have my contact information there for follow-up as well. Happy to talk about, any or all of these topics.
Gordon, thank you very much. That was, as you say, whistle-stop tour, but there's a lot more there, and I suspect for quite a few people today, it will be their first real exposure to this. It's kind of almost a hidden gem here we've got, so we need to get more folks learning about it. Obviously, the point of this. So, some questions that came in very quickly after you started talking, but I'll try and join some of them together. You've
Sure.
because you've kind of touched on them as you went through, but basically, question is, to the extent that you can say, who's using this in terms of agencies, program offices, etc., and what kind of systems are they trying to connect?
So there are, I think, two market segments really leveraging UDDL right now. A lot of it's coming out of the face, driven by face, because it is a supporting standard for the face architecture.
Right.
So defense, systems and mission and system integration, avionics, that real-time embedded systems exchanging data with other systems. So that's one big market segment in defense. And then also in the power and energy space, some of the large primes are leveraging UDDL to facilitate their own organization's integration of their hundreds of units of pieces of software. So again, in that space, I have all of these different pieces of kit, for lack of a better example, and then different instantiations and different locations will have different assemblages of those different pieces of software, right? This facility or plant needs 1, 2, and 3. This one needs 1, 2, 5, 6, 7. This one needs 1, 2, 250. So again, having formal models of all of those pieces helps the integrator reassemble them for effect into a specific deployed system. So we see some interest in other market segments. I think the autonomy space, again, not really, it's across many different markets, but folks are really beginning to realize that my autonomy algorithm really shouldn't be coupled to knowledge of the specific sensor that it's pulling data from. And the way that system's being integrated now, the autonomy algorithm, the smarts are coupled to the 27 sensors. When they change a sensor, they're back into that really exquisitely tuned autonomy algorithm, trying to touch its code and change its interfaces. And so they're seeing that the autonomy algorithm just needs to know, tell me what sensors are available, tell me what the data is, tell me what it means. I'll do some autonomy stuff and I'll tell you what to do, right? And then if I have other sensors that can proxy in, that enables them to deploy that automation without coupling it all together.
Okay, great. Thank you for that. Second question came in. Why would I use this versus SysML?
So SysML, let me go down one more slide here. So SysML, if you think about SysML, you have the data exchange type or the data type down in the bottom right. And that really is your modeled structure. And you can model and you can use the ISO 8000 packages to add additional rigor about logics, and then you can bind it to a code generator at float and stuff. And that's all syntax-based things. And that gets you to the physical, and if you're using the ISO 8000, the logical, units and coordinate systems and whatnot. But what it doesn't do is in the face version 2.1 or 3.0, there's a formal, that's the query effectively on the left, that tells me what that position is. So in this case, I am saying it's the air systems, navigation systems, observation of the airframe's position, right? And so that query gives me the formal definition of what that position actually is. I can put this also in SysML, but SysML does not have a mechanism then to connect the, I mean, you could duplicate UDDL in SysML without any of the formalism, without the MOF, without the OCL, and then you'd be building your own rules-based validation engine using, the plugin mechanism. So it's different. It doesn't overlap. And I've seen really good, there are many of the defense or the Department of War organizations and the primes using UDDL in a SysML environment to really good effect. Because when you start thinking about this, let me show you something here, right? If I start adding properties to my data exchange type, and now I'm added mode, I want you to see that as I click through, the model, that's the domain model on the top, is not changing. My query is effectively adding additional contextual information about the data in the message. So now with the same model on the top, I can create an exchange type that says the position of the vehicle as sensed by the sensor, the mode the sensor was in, and the validity of that sensed measurement. Right. And so that's something that is not doable in SysML. Over to you, Steve. Sorry. I can talk about this for all day. So
I know, Gordon. I know, and we are technically out of time, but we're still getting some questions in. But one was, can you show us an example, which is, I guess, something you just did there. So I'll wrap up with this last question, and it's how are domain-specific profiles being managed in UDDL, and are they centrally managed by the standard?
No, they are not managed by the standard. They are managed by the organization. This is in a UDDL file in XMI format. I would recommend going and grabbing the UDDL 1.2 standard and just giving it a read. It's very dry. It talks about the structure. It does not talk about governance. It does not talk about actual content. There are reference implementation. There are getting started guides out there, all published by the Open Group, that give you examples on how to get going. But governance, some teams are like, okay, there's a shared core. People can extend interfaces. There's methodologies for CCBs on top of UDDL where I extend, a property of the air vehicle, and I add a property that, hey, the air vehicle can actually roll. So it needs an orientation property. And so there are organizations that have a whole CCB to add that. But because every property and every element has a unique identifier across all of its renderings, then one can begin to actually trace changes, updates, do meaningful merges, and et cetera. That's another whole hour-long conversation, Steve.
And I know you did share on a previous slide, you did share your contact details. So if it's okay, people should feel free to contact Gordon if they want more information. As he says, the standard itself and getting started guides are all available on the Open Group website. Go to the library and you'll find those. And there's Gordon's details there.
Steve, can I make one last shameless plug? I would say get involved. The DIOG, which is the working group that curates and manages the UDDL specification, currently operates under the FACE Technical Reference Consortia. If you can join, and this is something right in your swim lane, please do, because there's work to do, and I would welcome users and perspectives from around the world on it. But at the end of the day, the published standards, and like I said, 1.2 is coming out shortly. Those are public and worldwide available, and they'll be available on the Open Group website.
Wonderful. Gordon, thank you so much for sharing your knowledge and insights today, and really appreciate it. And thank you to everybody who joined us and anyone who is listening to this on a recording. Thank you for taking the time out. Special shout out to Steve Davidson. I saw you were on here today. You're supposed to be retired. Anyway, thank you for sharing some of your retirement with us. The next special edition of Toolkit Tuesday will be on August the 11th, and additional information coming soon. We are going to be talking about the open dependability through assuredness standard at the Open Group, something in our security portfolio. It's a great standard that brings together a lot of different things. So please join us next time on August the 11th. Meantime, please stay safe and well wherever you are, and thanks for joining us. See you next time. Bye-bye.